Like a beached whale, the colossal machine lies derelict on the shoreline of the Caspian Sea. What was once one of the most secret projects of the Soviet Union lies rusting on a beach. When Western spy photos first discovered the Ekranoplan, it was dubbed the Caspian Sea Monster, and the name has stuck. This massive vehicle is a cross between a plane and a boat, and could speed across the water faster than any ship, using what is known as the ground effect to stay above the waves. With the fall of the Soviet Union, its fate was cast, and the Ekranoplan project was left to rot. However, the concept of large ground effect vehicles is making a comeback. The US Defense Department's research arm, DARPA, is working on a new vehicle called the Liberty Lifter. It comes from the Navy and Marines' need for fast ocean transport.
The Navy's looked at this thousands of different ways, probably over the years, depending on level of fidelity. We end up almost always coming back out. Seaplanes would be great. The Navy looked pretty seriously at ground effect seaplanes in the 80s. Obviously, when the Ekranoplan work was being done, we wanted to know what was going on there. But what Liberty Lifter does is bring the capability to do it in high sea states and real open ocean conditions. And also, we are really pushing on the ability to drive cost out of seaplanes.
Although the Soviet Ekranoplans and the Liberty Lifter may look similar, the physics involved is subtly different. The Liberty Lifter is kept in the air using the ground effect, which also keeps Formula One race cars sticking to the track.
A wing in ground effect operating for the aircraft or flying boat lift sense. A wing in ground effect is you're squeezing the air next to a surface. So if you think of simplify your wing as into a flat plate, and you have a flat plate, think of it then as a flat plate with a pressure acting at an angle. If that angle is 45 degrees, then you're going to have the same lift force as you have drag force. If that angle is 12 degrees, then you're going to have a much lower drag force for any given lift force. That, in essence, is what ground effect is.
For efficient ground effect, especially over water, bigger is better aerodynamically. In the 1940s, millionaire Howard Hughes built what was then the biggest aircraft in the world. The Spruce Goose, as it was called, was a gigantic flying boat. With Hughes at the controls, it can be seen powering up and never being able to break away from the ground effect in its maiden flight.
Compared to that flight, except that rather than a couple hundred feet, we are going to do it for half a mile or whatever it was. We are going to do it for thousands of miles.
Hughes designed the Spruce Goose to transport large quantities of material or troops over oceans, similar to the role of the Liberty Lifter. Boeing has a history of creating ground effect concepts and has the contract to build the demonstrator. A few years ago, it came up with the Pelican, which looks remarkably similar to the current Liberty Lifter.
We are building a demonstrator. So the demonstrator that the program is going to be building is going to carry the same cargo volume as a C-130, though it'll be quite a bit bigger than a C-130. And then the objective system, which is where we think the real sweet spot for a Liberty Lifter capability, is a C-17 sized aircraft. It's bigger than a C-17. So the demonstrator we're building is about 215-foot wingspan and weighs about 300 and odd, a couple thousand pounds. We look to be able to build a seaplane that can carry about what a C-130 carries for about the same cost as a C-130. But seaplanes historically have cost or almost an order of magnitude more than that per pound.
The Liberty Lifter isn't the only cargo-carrying ground effect vehicle in development. The Flying Ship Company has a design for a smaller commercial cargo transport.
It's actually a ship that flies. That's why we call it the flying ship. The IMO, the International Maritime Organization, and the FAA authorities have deem this to be a ship. It's literally in a similar category as hovercrafts. They float on the water, but they also go on a cushion of air. But it does have a flight operating component to it. So yes, people do ask that question often around, is it an airplane or is it a ship? We like to call it a flying ship.
One inherent problem to overcome for flying boats or maritime ground effect vehicles is salt water. The Soviets only ran the Ekranoplan in the Caspian Sea, which has a much lower salinity than the ocean. Even so, they had problems with corrosion, something both DARPA and the flying ship company had to address.
One of the things is at least in the plane that we're building right now, is actually building it with maritime composites. So we're building it much more like what you would build a yacht. Maritime grade composites don't really suffer if water ingression is prevented, and that has been demonstrated for millions upon probably billions of use hours at this point. The US-2 actually showed us a lot of the way on this, is they have an ability to wash down their engines in flight. We're looking to do the same. We've had discussions with specialist propeller manufacturers about marinized propellers, everything else. Nothing looks intractable as far as marinization.
Our approach has been to take proven technologies, such as electric motors for our propulsion, composites and materials that can survive a marine environment, and kind of put them all together. We all know there's artificial intelligence systems for detection, classification, and avoidance. Our role is to bring all that together and have a system that works in harmony in a safe and reliable environment.
The flying ship is in the early stages of development with small machines as proof of principle. What makes the Liberty Lifter program different from most commercial projects is how it will operate. With the concept vehicle able to travel more than 2,600 miles at 160 miles per hour, it's expected to be multi-crewed.
We plan to have this as a piloted aircraft because we plan to carry humans on it, even if it's not for the 30-hour trips. But we do plan the workload for that pilot to be automated to the maximum extent possible, much like they do on commercial airliners right now.
Automation is the way to go for the smaller flying ship. No crew, but with some manual remote control.
We don't believe we're going to be fully autonomous day one. I think it's too big of a jump. The regulators will have a lot to say what we can and can't do. They will likely allow us to go fully autonomous once we're in open waters, but I think that's, again, a progression based on the discussions we've had with the authorities. I think the typical operation point is you'll have to be manual leaving a port or a restricted area, enter into flight, and have some level of autonomy. And when I say some level of autonomy, it's around detecting, classifying, and avoiding targets. Buoys, large superstructure ships, rocks, those kind of things. And again, we're using flight proven technologies that are already on drones and other air vehicles of that such.
However, operating in the marine environment means that human monitoring is essential.
In the maritime world, you have what we call the co-regs, co-regulations, and it requires to have a lookout at all times. So there will always be a human in the loop, and we plan on achieving that through cameras and other sensors.
The flying ship is primarily a cargo vessel, and demand is driving development.
The customer and the use case drives the size, as we kind of talked about earlier. We do have a number of customers that are interested in what we're calling the 20-foot version. This allows us to carry cargo in the palletized state, whether it's in a container or on a wooden pallet. So when I say 20 foot, that's kind of the wingspan. The next level up from that is going to be 36 foot, so roughly 50% larger, 70% larger.
There is interest from Caribbean and Mediterranean cargo companies for shorter routes, such as inter-island.
They're in the business of moving cargo from point A to point B. Today they have trucks, they have airplanes, and they have ships. And this will provide a fourth method, flying ships, for them to move the cargo. As you know, ships move slow but can carry a lot. Airplanes move fast, but they can carry a little. We're kind of in the middle range there, where we can carry a decent size and move things quicker than a ship, and a lot more cost effective than an airplane.
The giant Liberty lifter is still a few years off. The demonstrator should be taking to the air by late 2027, joining what could by then be a fleet of smaller ground effect cargo vehicles, younger cousins of the venerable Ekranoplan.
Remember to hit the subscribe button and ring that bell to stay updated with our latest content. And while you're here, why not check out another one of our exciting videos? Thanks for watching, and see you in the next one.